Okay, so we've got 3 coins. So 2 are normal, and 1 gets heads 0.65. Right? So it says we toss the coin 4 times, and we get 4 heads. What's the probability that this is the biased coin? Right. Okay, so let's call these coins like A, B, and C, and say A is the biased coin, B and C are the other 2. All right. So what we want to find is the probability that we actually have A, given that we got 4 heads, right? To use Bayes' theorem, we need to find the other way around. So first we need to say, okay, what's the probability of getting 4 heads if we have coin A? How would we do that? No idea. Okay, so this is an and thing, right? We want to get heads on the first one, and on the second one, and on the third one, and on the fourth one, right? If you're doing and, as long as they're all independent, and we think, okay, the flip shouldn't affect the other flips, so that's not a big deal. So if you're doing and, you just multiply, right? So the probability of the first one's 0.65 times probability on the second one's 0.65 times probability on the third one. So probability of getting 4 in a row is 0.65 to the 4th if you've got the biased coin. So 0.65 to the 4th. So let me keep about 4 decimal places. So 0.1785 if you have the biased coin. What about the other 2 coins? What's the probability of getting 4 heads if you have one of the regular coins? What was that? Well, 0.5 for one flip, and then we're going to flip it 4 times. Was that? Yeah, 0.5 to the 4th, which is 0.5 to the 4th, 0.0625. Right. And same thing if you have the other non-biased coin. So both of those are 0.0625. Right. So if we use,
you know that coin A was the biased coin?
I don't. I just wanted to call them something. So I said, okay, let's call the biased coin A and the other 2 B's. I just wanted to be able to tell them apart. They're not really named. There was no A, B, and C in the problem. I just made that up so I could. I didn't want to write probability 4H given biased, probability 4H given first normal, probability 4H given second normal. So all right, let's call them A, B, and C. All right. So we're looking for probability of A given 4 heads. So according to Bayes' theorem, that should be probability of 4 heads. 4 heads given A times the probability of A. And then same thing again, probability of 4 heads given A times probability of A. Probability of 4 heads given not A times probability of not A. Right? Okay. So we just found this guy. This guy was 1785. What's the probability? I mean, if we just picked up one of these coins randomly, what's the probability we picked coin A? Yeah, 1 out of 3. Right. And so same thing on the bottom. 785 times 1 out of 3. And then since both these two are the same, so if these weren't the same, basically you just kind of split them up and you have 3 terms on the bottom, 1 for each case. But since they're the same, we can kind of do them together. So the probability of 4 heads if you don't pick A is 0.0625. What's the probability of not picking A? Yeah, 2/3. So let's grab the calculator again. 0.1785 divided by 3. That's my top. 0.0595, so divided by parentheses. 0.0595 plus 0.0625 times 2 divided by 3. If I did that right, 0.588. And of course, my pen quit writing again. Anyway, there we go. 0.58813 or whatever it was. Yeah, 14. Is that what you would have expected? It's like if you know you have a bias coin, you flip it 4 times, you get 4 heads. Would you think you only have a 58% chance of having the bias coin? Yeah, Lee thinks, man, if you get 4 heads, you should, that's definitely it, right? But apparently not. So, truth is stranger than fiction, right? Oh, and that was the last question. Oh, that's sad. Okay. Anyway, so again, in real life, that Bayes theorem actually comes up a lot because, yeah, okay. We're just going to leave it at that. Cool. Well, that's the end of homework 3. Are you happy to be at the end of homework 3? And again, homework 2 was due yesterday, right? So homework 3 is due next week, which means next Friday is the first test, which is over homeworks 1, 2, and 3. And Kirsten's eyes just got really big. So as far as what we want to do right now,